right, guys. For example number 4, let's do this color. Example number 4 out of our textbook. It says factoring a polynomial with complex zeros. So they give us a function f of x is equal to x to the 5th minus 3x to the 4th minus 5x to the 3rd plus 5x squared minus 6x plus 8. Okay? And it's a little fuzzy there. Let's try to focus and zoom in on that. There we go. All right, so now what we need to do, it tells us that they plugged it into a graph. And the graph, they plugged it into a graphing calculator. So maybe instead of drawing it out, let's do the same, okay? So I'm going to pull up a graphing calculator here. And let's plug this in. So I've got x to the 5th. Whoops. I'm going to use my other graphing calculator because it's a little faster. So I'm going to say y equals x to the 5th minus 3x to the 4th minus 5x to the 3rd plus 5x squared minus 6x plus 8. And it's kind of hard to see. Oh, oops, grabbed the wrong thing there. Oh, I see what I did. Did you guys see what Mr. Adams did? No wonder it looks silly. All right. You guys are supposed to tell me when I do stuff like that. Okay, I think I've got it all plugged in there, right? And I just need to zoom out a little bit here so we can see the whole thing. It looks like it crosses at x equals -2. And it looks like it crosses at x equals 1 and maybe possibly x equals 4, just by looking at the graph. Now, it's a 5th degree polynomial, and we've got some funny business here because of the how the graph is, the way the graph's set up. But when I zoomed out, it looks like it graphs through here. Maybe I should graph it on the other one. Let's graph it on the other one. But it looks like that minus 3x to the 4th minus 5x to the 3rd. It's weird. One of these graphing calculators works great on some functions, and then the other one works a little better on others. I never know which one works best. This one does great for like mathematical relationships that aren't necessarily functions. All right, so yeah, so look. So by graphing it, it looks like it crosses right here at -2, 1, and 4. Okay? Does that make sense? So those are real solutions. It's a 5th degree polynomial, so what does that mean, possibly? Well, then what it means is that there's probably a pair of complex solutions, right? Because there should be 5 solutions total. Okay? So now, if I set every one of these equal to 0, I get x plus 2 equals 0, x minus 1 equals 0, and x minus 4 equals 0. So that means I have f of x times this times this times this. But now I need to verify that. So what I can do is we're going to do a bunch of synthetic division to see if these are actually solutions. So I'm going to say -2, and then I have my x to the 5th x to the fourth, x to the third, x squared, x, and then x to the 0. And I'm just going to list the coefficients. 1, negative 3, negative 5, 5, 6, and 8. Okay, I'm going to drop my 1. Then negative 2 times 1 is negative 2. Add those up, I get negative 5. Negative 2 times negative 5 is positive 10. I get a positive 5. Negative 2 times negative 5 is a negative 10. Or I said it wrong, but I wrote it down right. This gives me a negative 5. This gives me a positive 10. Right? Oh, this is supposed to be a negative 10. So, or negative 6. So then this becomes positive 4. Negative 2 times positive 4 is a negative 8. This is my remainder of 0. So that goes into it for sure. Now remember, this is x to the fourth now, x to the third, x squared, and x, and then plus the coefficient, or the constant. So now what I want to do is I want to try and see if 1 goes into this. So I'm just going to go through, and one by one, this is definitely a factor, and then I'm going to check this and check that to see if there's solutions, okay? So then I drop the 1 down. 1 times 1 is 1. That gives me negative 4. 1 times negative 4 is negative 4. That gives me positive 1. 1 times 1 is 1. Negative 4 times 1 is negative 4. A remainder of 0. Now this drops a power again. This is x cubed. This is x squared. This is x. And this is the constant. So that one checked out. Now I'm going to do the same thing with 4. Synthetic division. Drop the 1 down. And 1 times 4 is 4. I get 0. 0 times 4 is 0. I get 1. 4 times 1 is 4. And I get a remainder of 0. This is x squared. This is x. And this is 1. So now what I've done, and I don't know if you guys realize this or not, we said that f of x is equal to x plus 2 times, or the quantity x minus 1 times the quantity x minus 4. And that comes from all this stuff up here, right? Times, and the stuff that's left over is x squared plus 1. Now that comes from this right here. That's where I get that from. So now the only thing I have left to do is I've got to split this up. So now to split that up, what I want to do is I want to think to myself, okay, x squared plus 1 has to equal 0. X squared equals negative 1 if I move the 1 to the other side. Now what do I do? Take the square root of both sides, and I get plus or minus the square root of negative 1, so x is equal to plus or minus I. Do you guys see what I did there? So now what does that mean? Well, what that means is f of x, completely factored, complex and real zeros, is x plus 2 times x minus 1 times x minus 4 times x plus, what do I put here? I, very good, and times x minus I. Do you guys see what we did there? That's it. That's all we have to do. Does anybody have any questions on that?